Hi, welcome. My name is Orsolya Bali, and in this video I'm going to demonstrate you the features and the functionalities that we've added to a terminology authoring tool, Snowball, to support the editing and the creation of the Singapore Drug Dictionary. The topics that I'm planning to cover today will be related to creating a medical terminology from adding a source definition, doing quality assurance, and then generating actual ontological content. We will look into how this generated output looks like for generic and branded products, for example, and how the actual maintenance happens when you update a description, for example, on your drug product. Before we get started with the workflow, let's take a look at the screen and get a little bit familiar with the Workbench. I'm not going to cover anything that is strictly Snowball City related today because we have a few, actually quite a lot of tutorial videos on YouTube where you can learn the basics and the more advanced functionalities of navigating and updating Snowball City. So what we're going to look at today in Snowball is the Singapore Drug Dictionary authoring perspective. This is the default setting of this perspective. On the left hand side you can see the Snowball City concept hierarchy. You can navigate the hierarchy and dig deeper down by the ISA relationships in between the concepts. You can as well, just for a reference, look at the ATC classification system in another navigator. Double-clicking any of the elements will open them in an editor where you can view more details of them. On the right-hand side, there are three different tabs. The task list one is associated with the workflow. We're connected to a Bugzilla task repository, and we're going to work through that. This is the part that I'm going to demonstrate at a later point today. On the reference set navigator, we have a large number of reference sets from the Singapore extension of Snowball City. Reference sets are basically collections of concepts that are collected for a certain reason. One reason can be is that they are used to define a drug product. These are the so-called supporting data reference sets here. For example, there is a dose form reference set in which I have not me, I'm sorry, in which our Singaporean users have collected all the dose form related concepts from the Snowball City terminology, and when you add the definition for a drug product, so when you define the attributes of a particular drug, for specifying the dose form, you're going to select from this list. So this is all the valid dose forms that are used in the Singapore Drug Dictionary. Similarly, there are ingredients and flavors and many other reference sets. Another type of the ref sets is the map type reference sets, where you have the option to create different mappings between the Singapore Drug Dictionary concepts and other terminologies or code systems. As you can see here, we use ATC, there is the GPO, the General Purchase Order codes, GT numbers and SIN numbers for registration. Right now these are not populated. The ontology preview is something that is going to be used for the source drug editing. When talking about source drug, I'm talking about the items in this bottom view. These are the source medication data items. Each item represents a particular drug product. You can double click and open it in an editor. This is a very simple drug that we're looking at right now. You can see that there is on the product page there is a hierarchical organization of this drug structure, which have a top level section holding all the branding related information. this is the pack part, packaging, or the product pack. This is the highest level. Each pack can contain multiple subpacks. Subpacks do not really have any particular properties. A subpack can have one or more components, and attributes like the DOS form are defined on the component level. This means that in a subpack you can have two different components and each having a separate DOS form. And each component can contain one or more ingredients, and on the ingredient level you can specify the actual ingredient, the basis of strength substance, and strength values of different strength types, and there are some additional properties. And this drug is as simple as it is. You can see that there are no other properties, but if we open, for example, a more complex one like Femoston, already in the navigator you can see that you can expand it, and if you expand you can view that there are two different packagings in which this drug is distributed. Let's stick with the product page for a moment. Now this is a more complex structure because you still have one subpack, but in this subpack you have two components. One is a single ingredient component and the other has two ingredients within the component. So you can see that this is a bit more complicated than the amoxicillin one. And of course this number is completely dependent on the actual drug product. We do not put any limitation into how many ingredients are allowed or how many components we support within a subpack. If you go to the packaging page, you see that it's a very similar hierarchical structure that we display here. There is the top pack level where you could specify the number of super packs if it's applicable, and some additional properties related to branding or adding other external identifiers as a mapping. Each pack has a number of subpacks. In this case there was only a single subpack, and you can select a container for the subpack and specify quantity values. And in the subpack there are two components. These are the two components that we were looking at. This first one is the single ingredient component, while the other one was the dual ingredient component, and each component has different quantity values. This drug is distributed in two different types of packagings. One is the 3x28 tablets, while the other is just once the 28 tablets. But it is still associated with the same drug product. So in order to create a drug like this, you have multiple options. Right now I'm working with a standalone client, but just for demonstration purposes, what I'm going to demonstrate is how the collaborative authoring is done. In a normal setting, for example with Singapore, there is a collaborative authoring server and clients are connected to that collaborative authoring server. Each user is working on its client, and each user has a number of tasks assigned to them that they're working on, and these tasks are tied to branches of the repository, and as long as the editing is ongoing, the author is working on these repository branches. Once the editing is completed, the repository branch content is being reviewed and verified by a reviewer, and after this verification process is completed and the content is confirmed to be good to go, all the content is moved to the main repository. The main repository is always the source of truth. This is what you use for publications, for example, or for different export-output generations. So what I'm going to demonstrate now is the source drug authoring process from the very beginning, that you have no source drugs, to the end point that you have the actual SNOMED City concept created from the source drug. For authoring, I need to create a new task, and I'm connected to my local Bugzilla repository, and this new task will be about creating a new source drug of Nurofen. I need to specify a task title, and you can add more details to the summary. Normally, this is it's a project management type of activity to create this task. It is similar to assigning a work to someone. The next step is to select which editing option I would like to undertake. I'm going to create a new medication source data. Since the data is tied to the SNOMED City version, I need to specify a version, but the latest version is automatically selected here. And even though for SNOMED City content authoring we have dual authoring, dual blind authoring, and dual review scenarios, for the medication terminology authoring we only have a single author and a single reviewer, simply because it was the workflow requirement from our current customer. And for this demonstration, I'm going to be both the author and the reviewer on this task. Finish will submit my task to the Bugzilla repository, and I can open my task in the task editor to view these details. These are the very same details that we've just entered on the wizard. You can see that the author is activated or is displayed with bold, means that the next step to be taken on this task has to be the authoring work by the author. So in order to start working on this task, I need to activate it first. Pay attention to this button, information bar. Right now it says no task activated, but if I click this activate task button, then my information bar will show the task ID and a hyperlink to open the task editor, but it is already open at this point. And at this very moment, I opened a branch on the repository, so everything that I'm editing from now will be only persisted on that branch and will not be merged back to the main repository. We call it a promotion. Will not be promoted back to the main repository until a reviewer verifies the content. So this is very important to keep the content of the main repository correct and consistent. I can open the artifact that I need to create just by clicking on this hyperlink. And now we're at the source drug editor and we can start adding the details. I like going from the ingredient level. So first I select the appropriate ingredient, which will be ibuprofen. You can see that there is a list here. This list is populated from a reference set where we collected all the ingredient concepts, all the substance concepts from the SNOMED hierarchy. So you don't need to browse through all the 400,000 SNOMED City concepts, only these 2,000 or 3,000 that can be used as ingredients for the drugs. So I select ibuprofen here, and the basis of strength substance is already automatically populated because based on certain relationships in the terminology, this medication can only have ibuprofen as the basis of strength substance. I add a strength. Let's make it 200 milligrams. 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 the units as well are selected from a unit of measure reference set. I will expand my editor a little bit so it's easier to read. And you can see that there there is an error on my source drag editor because I haven't yet specified the dose form. Similarly to the ingredients and the units, clicking in the dose form field lets you select from a list of predefined dose forms. These values are all coming from the dose form reference set. I'm going to add oral tablet. Also, there is a trade synonym for it that is going to be used in the descriptions of the drug product. Nothing to specify on the subpack, and since we also want to have the generic and the branded, I will add a trade name and we'll complete the drug definition at this point. There are two warnings. I should have added some mappings that I can skip for now. And also, even at a later point, it's possible to add different packagings, but let's not do that now. I save my medication and go back to my task page. As an author, I think I can consider my work to be completed because I created the drug Nurofen as it was specified in the task description, so I change my task's state to enter. By this state change, you can see that the author is now an inactive member of or an inactive role, and the reviewer became bold. This means that the reviewing work can start, and someone should now open this task, activate it to get to that repository branch, and check the source drug that I have created. I'm on this repository branch. I can see the source drug that I've created. It's here in the source drug editor Nurofen. But if I inactivate my task, I'm going back to the main. As you can see, there are no tasks activated, and as you can see, there is no Nurofen in my medication source data list. So let's assume that I switched roles and I am now the reviewer. I open this task and activate it, and I have the option to review my medication. You can open the source drug from the source drug editor, take a look at it, and at this point I should specify a review. I needed to refresh my task editor to make sure that it's fully synced with Bugzilla. And in this field, I can set an acceptance, or if I, for some reason, do not like the solution for this task or do not like the source drug, then I can as well reject it with some comments and send it back to the author to facilitate some more work or updates on the source drug. But I'm going to accept it as is because it looks good, and I will save my reviewing comments here. And as well, I set my task to reviewed. Now this is the point where you can see that there is a number of buttons up here, and this one, the Ontology generation one, became activated. This means that we have entered a source drug, and the source drug is now in its final state, so it is ready to be transformed into an ontological representation. So from that source drug definition that we entered in that form-based editor, we're going to generate a hierarchy of SNOMED city concepts. It is possible to guess in advance what the hierarchy is going to look like that we will generate. So if you open the source drug, we have this ontology preview view here. And by enabling this ontology preview, you can have a preview, a preliminary idea of how the hierarchies will look like. So you will have a high-level concept with the synonyms listed on the tooltip, and you will have more detailed concepts, and you will as well get some branded content. There is a lot of additional information that we display here, but you can hide those. These MP, MPF, MPR, these are the abbreviations for the Singapore Medicinal Product Class. MP is the highest level, where only the active ingredient is specified. MPF, the medication product form, is a little bit more detailed with an active ingredient and the dose form. The medication product preparation, called MPR. Here you have an ingredient, a strength, and a dose form. And for the branded drugs, you have an extra T in the Singapore Medicinal Product Class. So for example, this is an MTPR, a medication trade product preparation trade, because it has a brand name and it has an ingredient, strength, and a dose form, so this is a preparation. And the Singapore class hierarchy is very complex. There are over 50 different classes that we generate to match each and every use case and every particular care setting. But for the basic prescribing and dispensing use cases, probably a much smaller set of classes would be sufficient of maybe 6 to 8 different classes, and the classes that you see here are quite representative of the most frequently used classes. Anyway, this is just a preview, so it has nothing to do with the concepts yet, because for getting to the concepts we need to generate ontology, and I'm going to do that with clicking this button. I will close the source drag. Ontology generation, as you can see, I've run already a few generations earlier this morning. Ontology generation is normally a long-running process. That's why we added a functionality to run it in a batch mode, so it could be run as an overnight process whenever there is a release cycle, for example, or there is a need to add new source drugs and transfer them into SNOMED City. For this particular use case, it is not going to take that long, because I only have a very simple source drug, and my ontology in its current state is not too big, because I only have a few drugs generated. So it should finish in 2-3 minutes. In around 2-3 minutes. The ontology generation has two phases. One is when we create the actual concepts that you've seen in this ontology preview, and the other is when we run a description logic classifier, and this description logic classifier helps checking whether there are any equivalences between the newly created concepts and those that are already in the ontology, because it's possible that someone has already added an ibuprofen just under another brand name, but in that case the top level ibuprofen would already be present in your hierarchy, and you would not want to recreate the same concept multiple times, because that is not a good practice in an ontology, and we avoid having equivalent concept definitions and duplicates in our ontology. So the description logic classifier is checking that on the first place, and on the other side it is responsible for building the proper concept hierarchy. And it looks like it is just about to finish. I got some notifications from the server that my changes have been committed to this repository branch that I'm working on right now with my task. And I'm the reviewer now, so I need to go to the review tab and see the changes that are associated with my actions. You can see that there is a hierarchy here with the green components displaying the newly added content. You can as well check what type of additions happened on the task. So besides creating a new concept, we added a number of new descriptions. And there are some administrative or modeling content changes in the ontology as well that is not particularly relevant from the pharmaceutical perspective. So we're more interested in the new additions here. As a reviewer, I can check this content not only here but in the actual SNOMED tree. If I search for Nurofen, I can see that here I have these concepts with the tiny Singapore flag, so these are now added to my Singapore drug dictionary. If you open a concept, then you can see more details, including descriptions and additional relationships in the concept editor. At this point, this content is still only available on this repository branch. So if I inactivate my task, then you can see that I don't have any matching content in the SNOMED City tree, and on the medication data navigator I still do not have this Nurofen drug present. If I go back to my task, then I'm able to view the generated hierarchies again. So I consider this review to be completed, and we're going down on the happy path. Everything is accepted, but it would be possible still at this point to reject the generated ontology. You can see that there is this discard button activated, which would discard all the content that has been generated, and then the author would start making modifications again on the source drug and generate the ontology again with those modifications considered. I'm saving my editor with my review comments. And as a last step here, I will set my task to verified. Verified is the last task state that we're using. And once in a verified state, our task is ready to be promoted. So the content from the task is going to be merged onto the main repository by clicking on this button, which is for promotion. I click the button. I will merge my changes into the main branch and close the task because the editing is completed on this task. And at this point you can see that we have no tasks activated, so we're on the main repository, but we have the newly created content already on the main, and Nurofen is present in the medication source data navigator as well. So this is from the very first steps from scratch to how to create. This was the workflow of creating a source drug from scratch. You also have the options to update these source drugs using a very similar workflow mechanism, or you can import source drugs that were created with other clients or on other servers, and after importing as well, review, generate SNOMED City concepts and merge them. What I wanted to demonstrate is how you update something within your drug. So let's assume that your drug is already on the main repository. Moreover, it's possible that you have already published it, but you would like to update something in the drug definition, and for that you again have to work on a task to ensure that proper review happens. And we will update the description. I'm going to select this drug at this time because I want to make updates on an existing drug. And similarly, I will be the author and the reviewer again. So, in order to start adding these modifications, I need to activate my task. And I will open Nurofen. And let's say that what we'd like to change is the strength, because in the preferred term, I would like to make sure that the strength is expressed in grams. For that, I'm going to enter the value that I would like to add, and the defining strength is automatically updated because it always follows the preferred strength unless you specify something else manually. So let's keep the defining strength as it was, so 200 milligrams. You can see that if there is no match between the two strength values, you get a validation error. So we're using a conversion base to convert all strengths in the background and validate them that they're consistent. So I'm going to change the defining strength back to 200 milligrams. My error is gone. I only have the two warnings about the missing mappings, which is fine. And my preferred term is going to be updated to express this strength in grams. I can save my medication. And once again, as an author, I can consider my work to be completed, so I will set my task to entered and just inactivate, leave, and move on to the next task. Now the reviewer should be active, which I set myself to be a reviewer, so at this point it would be my task to review these changes. If we inactivate the task, you can see that Nurofen is present on the main, but with 200 milligram as the preferred strength. But if we activate the task again, you can see that the Nurofen preferred term has already been changed to the one that was specified on the task. So I should review. If I can't add the review, then I can refresh my task to make sure that my review field is activated as per it should be because of the task status. I accept these changes. And I'm not adding any comments, but I set my task to reviewed. At this point, you can see that the ontology generation button is again activated. This means that now my source drug changes are checked, and I'm ready to transfer all these changes to the ontological representation of this medication. So for this, I need to regenerate ontology again from this Nurofen. We're using different rules to merge this regenerated terminology to the already generated one. So for example, in this case, we are not going to create new concepts. We will just make sure that the descriptions of the already existing concepts are updated, and if they had an attribute of preferred strength, and that is true for the medication product form and the medication trade product form levels, then that attribute as well is updated to reflect the grams instead of the milligrams as it was set previously. And we're getting closer to completion. I got a notification from the server that my changes have been committed. And on the review page, we can check what these changes are. You can see that nothing is green now, so there are no new concepts in the hierarchy, but this tiny delta indicates that some things have changed. And the changes include detaching a few descriptions that were originally displaying the 200 milligram as the strength, and adding new descriptions of the same types that are displaying the 2 grams. And these changes are only applicable for those drugs where the description displays the strength. So the MPR and MTPR levels. The above hierarchical components are not affected. So we can accept these changes. And actually at this point I'm repeating the same steps as I did for the previous task. So after the ontology has been reviewed and accepted, then we can set the task to verified, and once it's in a verified state, then it can be promoted to the main, and we can make sure that all the changes are merged, and all the changes that we merge were previously reviewed. So we still have the filter on the SNOMED City hierarchy, and we can see that even though we're back on the main repository, our changes are reflected here because they've been merged from the task, and these changes mean that the descriptions for the relevant drug concepts have been updated. So the relevant concepts include the generic ibuprofen tablet and the branded one with the Nurofen trade name. So this was the workflow of applying an update on an already generated source drug and transferring these updates into the hierarchy. This is all that I wanted to show you today. Thank you for your attention and time, and have a very nice day. Bye.